Hello, dear participants of ITNT 2020. First, let me introduce myself. My name is Kopeykina Lyudmila. I am the student of High School of Economics, and today I am going to give you the short overview on our research divided to photo privacy detection based on text classification and face clustering techniques. Today I am going to start with photo privacy detection problem, and then I will describe the proposed approach to detect personal photos in users gallery. Then I will give you the overview of our experiments, and finally I will make up some conclusions and describe future plans. Nowadays, photo privacy detection is becoming an acute task due to a widespread of mobile devices with photo published on social networking sites. As a photo might contain private or sensitive data, there is an urgent need to accurately determine them and impose restrictions on their processing. The privacy detection of photos is a worth considering problem that has already reached a certain level of maturity. However, the existing methods have some limitations. For instance, in general, the decision on a particular photo can be made based on its visual appearance. It means that when a text, for instance, is detected in an image, the neural network will attribute it to personal data, while this text may not contain any private information at all. So we need to analyze the context and the semantic of this text. The same situation is observed with the detection of faces in images. Not every image with a face detected on it is confidential. Our approach overcomes these limitations. As the vast majority of private images mainly contain such characteristics like human faces and textual data, we proposed a unified approach for personal data detection in photo gallery using well-known methods of face classification and text recognition. In this work, we concentrate on the following task. It is required to assign an image from photo album to one of two possible classes: private images and public images. Personal photos can't be transferred to the third parties in terms of privacy policy, and public information can be sent to a remote server for further deep processing and analysis. Additionally, we can use public images from users gallery to model his or her preferences on the remote server using sophisticated techniques like deep neural networks, and private images can be processed locally on the mobile device of the user. On that slide, the proposed approach is displayed. First, we suggest to detect scanned personal documents using AST text detector, the Tesseract serial library, and the neural network classification of recognized text on images. The second stage is devoted to detection of users' personal photos based on the well-known methods of face clustering applied to face embeddings. So let's go further and let's discuss that steps in details. At first, areas with text are detected using the EST algorithm. Then we extract text from these areas using Tesseract search engine in image-to-screen mode. Then we classify personal data with the help of a neural network classifiers, which are trained based on the input sequence of words recognized in the training set. Each text from the image was represented as a v-dimensional binary vector, where each component of the vector is 1 only if the word from the dictionary is presented in the input text. Neural network classifier returns the label of class, private or public, according to the input sequence. In addition, we detect photos, personal photos, based on face clustering techniques. First, facial regions are detected in all photographs using well-known face detection methods. Then we extract feature vectors with the help of various convolutional neural networks. Finally, we assign each image to one of the C groups, where C is usually unknown. An image is considered to be private if it contains faces from sufficiently large clusters. In other words, a person should present at least car times on different types of photos, where car is a hyperparameter of our method. So the approach is presented on that slide. And now I'm going to describe the experimental results of our research. Firstly, we compare simultaneous detection of text on images and its recognition using Tesseract with the approach when text regions are preliminarily detected by EST detector and text is recognized by Tesseract OCR engine. We conducted our experiments in terms of various classification methods like traditional keyword spotting method and various neural networks like convolutional neural network, fully connected network, and recurrent network with an LSTM lawyer. According to the results, we can conclude the proposed implementation with EST detector increases the average accuracy by approximately 2%. A fully connected network achieves best results with accuracy that exceeds even traditional recurrent network. Moreover, such an implementation 15% more accurately determines the image class of the document in comparison with the traditional keyword spotting method. Finally, we compared face clustering techniques, and for doing that, we use two publicly available facial datasets that are presented on that slide. Namely, it is Gallagher collection and a subset of label faces in the wild. We compared several clustering algorithms. First, we look at agglomerative clustering with various types of linkage like single linkage, average linkage, complete linkage, etc. Then we look through rank order clustering and its approximation. And finally, we applied graph convolutional neural network to get clusters. To extract facial features, we considered various CNN models, and they are presented below. To analyze the results, we calculated various methods. They are displayed also on the slide. Namely, it is the rand index, mutual information index, and the B cubed F measure. So, let's speak about the experimental results of face clustering. Clustering applied to facial features extracted with VGG Phase 2 and FaceNet perform more accurate results according to most of the metrics compared to other models. Moreover, inside face features in most cases shows slightly worse capacity to define clusters. In addition, weighted linkage demonstrates a high F-score for both datasets in comparison with other clustering techniques. As you can see, the same tendency is demonstrated with the Gallagher dataset. In the final experiment, we analyzed the dependence between the minimum number of faces in cluster to set it private and the type 1 and type 2 error rates for the LFEW subset. According to the achieved results, zero rate of missing private and public photos is achieved with CAR equals 2. Moreover, the trend of type 1 error is going upwards unstably and ends up with approximately 2%. At the same time, the probability to assign public images to private decreases and reached zero probability. So, in conclusion, it should be said that the task of personal photos detection is really difficult in terms of finding an effective solution due to its inherent subjectivity. In our work, it is assumed that personal data contains confidential textual information and images with the user, his close friends, and relatives. This assumption allows to highlight personal photos accurately and impose restrictions on their processing. So, dear participants of ITNT 2020, thank you for your attention. If you have any questions, I am ready to answer.